So this video is about the prevalence-incidence bias, which is a limitation of the cross-sectional study. So this bias and the limitation is related to the fact that cross-sectional studies are looking at prevalence of disease by exposure group. So they're looking at whether the exposure increases the prevalence of the disease. And the problem with this is that prevalence is made up of two things, both incidence and duration. So the prevalence of a disease equals the incidence of the disease times the duration of the disease. And so if you see that prevalence of a disease is higher in the exposed group than in the unexposed group, you don't know whether that exposure is related to the incidence of the disease or the duration of the disease. So if what you really want to know is whether the exposure is related to bringing on the disease or creating a higher risk of the disease, that's usually what you want to know. That's incidence, okay? But looking at prevalence data does not distinguish between the exposure causing the disease to occur and the exposure making the disease last longer or shorter. So going back to our example from before, we saw that obesity is related to a higher prevalence of diabetes in cross-sectional data of U.S. adults. And so what we're really interested in is whether obesity is causally related to diabetes. So does becoming obese lead to increased risk of diabetes or increased diabetes incidence? However, it could be the case that obesity increases the survival of diabetics. So if obesity increases the survival of diabetics, that is, if it increases the duration, then the association between obesity and diabetes prevalence will be higher, okay? And then that means that the risk of diabetes as a function of obesity will be overestimated. So that is, what you attribute to incidence will actually be attributed to duration. So when you're estimating risk, you're looking at incidence, you're inferring incidence from prevalence. But if the exposure has a big impact on duration, then that will increase the prevalence, okay, of the exposure. But it's not because it's higher incidence, it's just because it's affecting the duration. And so that results in an overestimation of risk. And then similarly, if obesity decreases the survival of diabetics, okay, that means decreases the duration, then the association between the exposure, that is obesity, and prevalence will be lower, because this will decrease you're trying to find incidence, but this being low will decrease the prevalence. But not because the risk is lower, it's just because the likelihood of survival is lower as a function of exposure. So in that case, the risk will be underestimated. So what these two things show is the problem with looking at prevalence data as an estimate of risk. So here's another depiction of the prevalence-incidence bias. So what this shows is each of these lines is a different case of the disease, and it lasts for a particular time. So if the cross-sectional study was done in July, it's looking at prevalent cases rather than incident cases. So it would have missed the cases 1, 2, and 4, which were the most severe cases. So the issue with the cross-sectional study and using prevalence data, again, is that the prevalent cases include the long-term survivors, and they may exclude some of the most serious cases, the people that get the disease and die very quickly. So this also shows that looking at incidence data is better, because with incidence data you get the full spectrum of survival of the disease. So in incidence data, if you were doing a study that lasted for this whole year, you would be tracking all these 8 people over the course of that time period, and you would capture the disease in all of these 8 people. And so incidence is not related to the survival, because you're looking at it over the course of time. Okay, so now we have described all of the descriptive studies, and overall the limitations of descriptive studies are that we can't test hypotheses about the causes of disease. And as we just saw, looking at the difference between prevalence and incidence, this is because for all of these descriptive studies, we have no information about the time course of the variable. So in every case, we're looking at prevalence data. Well, in the case of ecologic and cross-sectional studies, we're looking at prevalence data. In case series and case reports, we don't even have prevalence data because we don't have a whole population. We just have a series of individual events. But for these two studies, we're looking at prevalence rather than incidence, and for that reason we can't infer causality. So you might describe this as the problem of what came first. You don't know whether the exposure came first or the disease came first, and secondly, you don't know whether the exposure is related to the development or incidence of the disease or the duration of the disease. So those are the main problems with descriptive studies, and that's why they are not useful for inferring causality, but overall are useful for generating hypotheses that can be tested with these methods towards the top of the pyramid, which can look at causal relationships.